A motor that hums but requires a manual spin to start usually indicates a problem with the starting circuit or mechanical components. Here are some possible causes and solutions to troubleshoot. Firstly, consider a defective capacitor. The capacitor's primary function is to provide an initial boost of current to start the motor. If it's weak or has failed, the motor won't start on its own. Replacing the capacitor is often the first and simplest solution. Secondly, examine the bearings. The motor shaft relies on bearings to rotate smoothly. Rust, dirt, or lack of lubrication can cause these bearings to seize, preventing the motor from starting. Lubricating or replacing the bearings might resolve this issue. Thirdly, consider shorted windings. If the motor's windings are shorted, it can draw excessive current and hum without starting. This is a more serious problem, potentially requiring professional repair or motor replacement. Fourthly, a stuck centrifugal switch might be the culprit. Capacitor-start motors use a centrifugal switch to disconnect the capacitor once the motor reaches a certain speed. If this switch is stuck, the capacitor remains connected, hindering proper motor operation. Cleaning or lubricating the switch could alleviate this issue. Now let's delve into a detailed troubleshooting process. 1. Check the capacitor. Use a multimeter to measure the capacitance. If it has significantly degraded, replace it with a new one of the same specifications. 2. Inspect the bearings. Remove the end bells of the motor to access the bearings. Check for any signs of seizing or damage. If necessary, lubricate or replace the bearings. 3. Examine the windings. Visually inspect the windings for any discoloration, burns, or shorts. If you suspect winding damage, it's best to consult a motor repair shop. 4. Clean the centrifugal switch. Access the switch by removing the motor's end bell. Carefully clean the contacts and lubricate them with a light oil. When selecting a capacitor, ensure you choose one with the correct capacitance and voltage rating for your motor. Using an incorrect capacitor can damage the motor. When lubricating bearings, use a high-quality electric motor bearing grease. Avoid using general-purpose greases, as they may not be suitable for the high speeds and temperatures of electric motors. When inspecting the windings, look for signs of overheating, such as discoloration or a burnt smell. These indicate potential insulation breakdown and short circuits. When cleaning the centrifugal switch, be gentle to avoid damaging the delicate contacts. Use a contact cleaner specifically designed for electrical components. To measure capacitance with a multimeter, set the meter to the capacitance setting, usually denoted by a capacitor symbol or F for farads. Disconnect the capacitor from the motor before measuring to avoid inaccurate readings. Compare the measured capacitance value with the capacitor's rated capacitance, which is usually printed on the capacitor's label. A significant difference suggests the capacitor is failing. To replace bearings, you may need a bearing puller to remove the old bearings from the shaft and end bells. Install the new bearings carefully, ensuring they are properly seated. Avoid hammering directly on the bearings, as this can damage them. When working on electric motors, always disconnect the power supply to prevent electric shock. Use appropriate safety gear, such as gloves and eye protection. If you are not comfortable working on electric motors, it's best to consult a qualified electrician or motor repair technician. They have the expertise and tools to diagnose and repair motor problems safely and effectively. Motor bearings are typically sealed or shielded to prevent contaminants from entering. However, over time, the grease inside can dry out or become contaminated, leading to bearing failure. Some bearings have grease fittings that allow you to add new grease. Use a grease gun to inject a small amount of grease into the fitting until you see fresh grease coming out. Be careful not to over-grease the bearings, as this can also cause problems. The centrifugal switch is usually located inside the motor's end bell near the rotor. It consists of a set of contacts that are opened or closed by centrifugal force as the motor speeds up. The contacts can become dirty or corroded over time, leading to poor electrical contact. Cleaning the contacts with a contact cleaner can restore proper operation. The motor windings are made of insulated copper wire. The insulation can break down over time due to heat, vibration, or moisture. When the insulation fails, the windings can short to each other or to the motor frame. This can cause the motor to draw excessive current and overheat. Shorted windings can be detected with an ohmmeter. Measure the resistance between the motor leads and the motor frame. A low resistance reading indicates a short circuit. If the motor has shorted windings, it needs to be rewound or replaced. Rewinding a motor is a complex process that requires specialized equipment and expertise. It's usually more cost-effective to replace a small motor than to rewind it. Before replacing a motor, make sure to check the voltage, horsepower, and frame size to ensure the new motor is compatible with your application. A capacitor start motor utilizes a capacitor in series with the start winding to provide the necessary phase shift for starting torque. Once the motor reaches a certain speed, the centrifugal switch disconnects the start winding and capacitor. The motor then runs on the main winding alone. A capacitor-run motor, on the other hand, uses a capacitor in series with the auxiliary winding during both starting and running. This provides improved efficiency and power factor. Capacitor-run motors are typically used in applications that require continuous operation at a constant speed. The capacitor in a capacitor start motor is typically an electrolytic capacitor, which is designed for intermittent use. The capacitor in a capacitor-run motor is typically a film capacitor, which is designed for continuous use. Electrolytic capacitors are more sensitive to heat and voltage than film capacitors. Therefore, it's important to use the correct type of capacitor for your motor. The size of the capacitor is determined by the motor's horsepower and voltage. A larger motor requires a larger capacitor to provide sufficient starting torque. The capacitor's voltage rating should be at least 25% higher than the motor's supply voltage to provide a safety margin. The centrifugal switch is a mechanical device that can wear out over time. The contacts can become pitted or corroded, leading to poor electrical contact. The switch can also become stuck in the open or closed position. If the centrifugal switch is not working properly, it can prevent the motor from starting or running correctly. The motor windings are typically made of copper or aluminum wire. Copper windings are more efficient and durable than aluminum windings. However, aluminum windings are less expensive. The insulation on the windings is typically made of varnish or enamel. The insulation protects the windings from short circuits and grounds. The motor frame is typically made of cast iron or steel. The frame provides structural support for the motor and helps to dissipate heat. The motor bearings are typically ball bearings or roller bearings. Ball bearings are used for lighter loads and higher speeds. Roller bearings are used for heavier loads and low speeds. The motor shaft is typically made of steel. The shaft transmits the motor's torque to the driven equipment. The motor fan is typically made of plastic or metal. The fan cools the motor by circulating air over the windings. The motor terminal box is typically made of plastic or metal. The terminal box provides a convenient location for connecting the motor to the power supply. The motor nameplate provides important information about the motor, such as the horsepower, voltage, amperage, speed, and frame size. Always refer to the nameplate when selecting a replacement motor or capacitor. When working on electric motors, always disconnect the power supply and discharge the capacitor before touching any electrical components. Capacitors can store a dangerous amount of energy even after the power is turned off. Use a multimeter to verify that the capacitor is discharged before working on the motor. If you are not comfortable working on electric motors, it's best to consult a qualified electrician or motor repair technician. They have the expertise and tools to diagnose and repair motor problems safely and effectively. Remember safety first and foremost when dealing with electrical equipment and machinery. If the motor continues to hum after replacing the capacitor, carefully inspecting and lubricating the bearings, and cleaning the centrifugal switch, it is recommended to seek the assistance of a qualified motor repair professional to diagnose potential winding issues.